Hey Nerdinas, today we are actually going to start building our board. So in this video I will be walking you through everything that you will need to do before you start the 4 experiments. So this will include printing out data sheets, getting your microcontroller in place, and also setting up your programmer and the programming software that you will need for all 4 experiments.
So the first step is going to be to place this microcontroller into a socket. So you can see the microcontroller right here. It is a PIC16F877A. So the microcontroller is a mini computer and the brain of the board in that it sends commands to each of the components that it's connected to. In order to solder this microcontroller onto the board, the first thing you're going to want to do is place the microcontroller into a socket. So you can see here, this line, these are all of the microcontroller pins, and then I've placed the microcontroller into a socket. And this is just to make sure that it stays protected and that none of the pins on the microcontroller itself get bent out of shape. To show you what that looks like, turning this board over, this right here is the soldered microcontroller. And once you have done this, I would recommend printing out a data sheet for this microcontroller just so you can see where all the pins are and what connections you'll be making in the future. So in order to find the data sheet, you can write PIC16F877A data sheet, and I will leave a link for that in the down bar below. So this right here is what the data sheet looks like. Don't mind that on the bottom, but you can see each of the pins and their names, which will be very handy in the future. And I've soldered on the microcontroller in the same configuration that it is here. So just to orient ourselves, you can see this ridge up top corresponds to this ridge right here. So the first thing that you're going to want to do after you have your microcontroller soldered and in place is build this circuit right here. So the main components that you will need are, hopefully you can see that, a diode, 2 capacitors, 2 resistors, this LED, and a voltage regulator. So you're going to want to begin by soldering in your voltage regulator, and the voltage regulator is responsible for supplying power for the circuit. So the voltage regulator is directly connected to your battery, and it has 3 pins, in, ground, and out. And this is the 7805 voltage regulator, and to identify which pin is which, you're going to want to hold the regulator up like this and make sure that the writing is from left to right. And so in order from left to right, you have in, ground, and out. Just a couple things. The next thing that you're going to want to do is place a diode. So this is the diode that we will be using, IN4007. And a diode is any electronic device that conducts current more easily in one direction than the other direction. And once again, diodes have a positive side and a negative side. So in order to identify which side is which, hold the diode like this so that you see a small silver ring on the right side of the diode. Hopefully you can see that. And the side where you see the small silver ring represents the negative side of the diode. The next thing that you're going to need for this circuit is an LED, and the LED will glow if your circuit is being given power, and it's just a good way to check for that. So this right here is an LED, and once again it has a positive and negative side, and the longer lead is the positive side, the shorter lead is the negative side. Next, you're going to need a capacitor, and this right here is a capacitor. The longer lead is the positive side, and the shorter lead is the negative side. And lastly, you're going to need 2 resistors right here. And one of the resistors is 1000 ohms and the other resistor is 10,000 ohms. In order to build that circuit, you can refer to this part of the circuit diagram right here on the left. And once again, this part of the circuit is what is giving power to your whole circuit board. And you can see the connections right here. The next thing that you are going to want to do is solder on these 6 pins right here. And these pins are for this device right here, which is called the picket, and the picket is the programmer for your circuit. So the picket comes with a wire like this. So this device connects to your computer and it processes the program and sends it to the microcontroller. So these right here are the 6 picket pins. So in order to know where to connect the 6 picket pins, you're going to want to look at 2 diagrams simultaneously. So the first diagram is the picket 3 pinout, and you can search this by looking for picket 3 pinout, and this shows where each of the 6 picket pins should go. Second diagram that you're going to want to look at is this right here, and this is the 40 pins for the PIC16F microcontroller. So we can see that the first pin is going to MCLR/VPP, which is right here on the PIC microcontroller. The second pin is going to VDD target, which is right here and here, and because both of these are the same, we can connect them in the back of the circuit. So make sure to have a wire going from pin 11 to pin 32, and then from either one of those pins to pin 2 of the picket. The next connection is for VSS or ground, so just look for VSS on the PIC microcontroller, and we see that it's pins 12 and pin 31. So once again, have a wire going from pin 12 to pin 31, and then a wire from one of those pins to the third pin on the picket. So one quick note about ground and VDD: if you ever see ground and VDD anywhere on your circuit, you want to make sure that they're connected to the actual power supply of the circuit in some way. So picket pin 2, after it goes to the microcontroller pin should be connected to the regulator right here. So the 4th pin is going to be going to PGD, which is pin 40 right here. The 5th pin is going to PGC, which is pin 39, and the 6th pin is going to PGM, which is pin 36. And this is all represented on the circuit diagram also. I just wanted to show you those 2 diagrams so you can have an idea of where exactly we got each of those connections from. So you have the first pin going to VPP right here, and just a quick note, this might be a bit confusing, but pin 2 is going to VDD target, and that represents a power supply, but the power supply pin is not one of the pins included in this software's diagram of the PIC controller. So I've just made this symbol for power supply, but know that it should go to the VDD pin. This is the 3rd pin right here. It should go to ground on the microcontroller, which is also VSS. The 4th pin should go to PGD, which is right here, pin 40. So you can follow the 4th pin right over there. The 5th pin should go to pin 39, which is PGC, and the 6th and last pin is going to pin 36, which is PGM. So there you have it, the 6 picket pins, and flipping this board over, you can see that each of these connections has been made. And do note right here that the 2 VDDs and the 2 VSSs are connected through a wire. So the last thing that you are going to want to do before you can start the 4 experiments is download a program called NPLab IDE. And you can find this by just searching for the download on Google, and it should lead you to this page on Microchip's website. And now you can download whichever version is appropriate for the operating system that you are using. And then when you open the program, go into Configure and select the device that you want. So we want the PIC16F877A microcontroller, which I've already entered here. You also want to select your programmer, which is the Picket3. And now you want to go to your programmer settings to power and make sure that the option Power Target Circuit from Picket3 is selected. And this means that when the Picket is connected, it will power your circuit. You also want to make sure that you have a voltage of 5 volts, no more or no less, because this could ruin your Picket. In order to begin programming, you're going to want to create a new project by going to Project, then Project Wizard. Next, make sure that the device that's selected is PIC16F877A. Next again. And now you're going to create a new project file and just browse for a location to save your project. So I'm going to be making a new folder called Board Project, and then naming the main file for that board. Next, and just finishing up that. So now to create a new file, I'll put add new file to project. I'm going to name this file test. Make sure to write .c to specify the file type, and save that. And now you have your first file ready to go to write your program. So in the next 4 experiments, when I'll be showing you the programs and what to write, you'll want to make sure that you're typing the programs here. So when you ultimately connect your programmer and go to run your program, you'll go to Programmer. Once again, make sure that your programmer is selected as Picket3. You'll put Reconnect, and your programmer should be connected. And then this program option will be available, and you'll be able to run and test your program. So now that we have set up our PIC microcontroller, our Picket pins, printed out the data sheets that we need, and also set up the Picket programmer software, NPLab, we are ready to begin our 4 experiments. So the next video will be showing you how to do the first experiment, which is the 3-bit LED counter, and I will be back with that very soon. From each Nerdina to all Nerdinas. Adios.